All right. Thanks everyone for joining today. Appreciate you taking up the time. I know the beginning of the year can be pretty busy for everyone. So we've got about half an hour here. So the main point of our discussion today is really focusing on how HydroForecast can be used to improve water management supply. I know we've got some folks on the call who are existing users in hydropower and other organizations. And today our focus is really going to be on in places where you have dams or are managing water supply, how HydroForecast can support that experience. So I'll spend about probably 15 to 20 minutes starting out by just presenting a little bit about who we are and what we've built with HydroForecast. And then in particular, talking about how HydroForecast can improve water supply management, talking through some use cases of what it might look like to have HydroForecast in different circumstances and hopefully be able to make better decisions. And then definitely I'll carve out some time at the end for questions and discussion. So just at a quick glance, we at Upstream Tech are a company of a little over 30 people. We have sort of an interesting makeup. So our team includes both technologists, and by that, I mean folks who are software engineers or machine learning engineers, as well as folks with specific experience in the domains that we work in. So looking at water resource management, hydrology, earth sciences. And our overall goal in having this sort of team is so that water resource managers can really get the best of both of those two domains in understanding what conditions will be like in the area where they're working and be able to have the most accessible and useful information at their fingertips when they're making decisions. With HydroForecast, we work with a couple different organizations, about 24 different companies across the water utility, hydropower, government, and conservation range. We've got live forecasts on almost a dozen different countries, and we inform a little over 9 gigawatts of hydropower. So what we've built with HydroForecast is really a tool to be able to understand how much water is going to be coming into a specific place at different points in the future. And when you look at inflow forecasting, some of the unique things about HydroForecast really tie back to the way that we have built the structure overall. So we use an approach that we call theory-guided machine learning. And basically what that is a way to get the best out of both machine learning options, as well as traditional statistical or conceptual hydrologic models. And this architecture allows us to bring in new information. So we have, as far as I'm aware, the most robust system for bringing in multiple weather forecasts, satellite Earth observation data, and on-the-ground sensor or other in-situ data live and in real time for creating forecasts. And so while that's interesting from an academic perspective, really there are just a few operational reasons why that actually matters for folks who are trying to do water resource management. The way that we make these predictions are on different time horizons. And so the focus that we're going to have today is really looking forward. So how much water is going to be coming in at different points in the future, whether that's what we call short terms, the upcoming hours and days, out to what we call seasonal or extended, looking multiple months ahead, and then even looking further into the future, multiple decades down the line to understand how climate change might be affecting flows within a basin. So the main reason why most of our users turn to HydroForecast, sort of the table stakes for this conversation, is accuracy. If we are making predictions about what the future will look like, being able to do so more accurately is the place where we can often add the most value. One way that we were able to validate that HydroForecast actually is more accurate than the alternatives was to participate in a year-long competition where every day we would submit forecasts for the upcoming 10 days at about 24 sites across the US and Canada, and then other leading forecasters. So the US government, some of the largest utilities, other private vendors also submitted their forecasts, and a third party went and evaluated the results. The finding was that across each of these different regions, so places like the US West and the Northwest that get a lot of moisture and snow, down to the South and Southeast that are much more rain-driven with flashy storms, and up in places like Quebec, where you're dealing with significant freezing and large snow-driven events, HydroForecast was able to improve forecast skill across the board. That's not just at the short-term horizon, but also looking multiple months ahead. So if you're a water resource manager trying to understand your supply for the upcoming months, HydroForecast really has shown that some of these methodologies can improve skill there as well. So what you're seeing here is a graph of about this time last year, our predictions for how much water would be going into 5 of California's largest reservoirs in April of 2022. And we were consistently able to make forecasts that were both more accurate than the historical average, as well as more accurate than what the state's official Department of Water Resources forecasts were showing. Some of this is that the way that we've built HydroForecast is not just calibrated to be very accurate right now, but we've actually built a system that is adaptive and flexible to be responsive to climate change and extreme events. So going forward, as we're going to have more and more events that are likely to be historic, either very large storms or very severe droughts, the architecture behind how we created HydroForecast is actually responsive to that and ensures that the model will continue performing during these extreme and unusual conditions. The last thing that I'll highlight is that what we've built with HydroForecast is also meant to really get sort of actionable information into decision makers' hands. And there are a few key ways in which we've done that. So the first is that our forecasts are all probabilistic, meaning that they don't just provide a single trace of what we think is likely to happen, but a full range of possible outcomes, showing the uncertainty at different times. We also include things like thresholds and key forecasts, so users can see if flows are expected to go above or below a certain point. They can see that information really quickly and cleanly. And we produce the forecasts in a way that is resilient to any of the data inputs or staff going down, so that if, for instance, the official government weather forecasts went down, we have other sources that we're still able to pull from and produce the forecasts. Finally, HydroForecast is really easy to integrate into existing other systems that you might have in-house for managing your reservoirs or your dams. Great. Okay, so I know that was recap for some of the folks here, hopefully new for others. But let's talk specifically about water resource management. So what I'm going to do here is I'm going to run through a couple different examples of cases where having some of those features that I just talked about and some of those improvements that I just talked about can be useful for water resource managers. And to do this, I just went through and pulled a few examples of HydroForecast over the past year or so. These are not cherry-picked examples of the model doing exceptionally well. I was focused much more on just what is the specific instance and how can we show what HydroForecast is giving to users during those situations. So one of the main things that we hear and one of the main uses that our users care about are managing upcoming releases. So consider a situation like this. This top chart is showing potential flows for the upcoming days. And you can see this dotted line showing the US government's, NOAA's River Forecast Center, prediction for a large inflow event. This is happening in late May. So if I'm a water resource manager, I'm probably going to want to hold on to as much water as possible so that I can have that later in June and July and August as things are pretty dry. If this sort of single trace that NOAA is showing happens, I may have to release water to make room for the storm without there being any concerns. What you can see is HydroForecast predicts a lower event. It shows that there's the possibility of it getting much higher, but based on things like disagreement in some of the weather forecasts and these diurnal fluctuations showing things hovering just above freezing, we think that there's likely to be less flow than NOAA shows. Now, since this event already happened, we can go back and look and see what happened. And we see this consistent line coming through that matches much more closely what HydroForecast showed. And so a water resource manager who'd been able to follow that guidance may have been able to save some water that they could then use later in the year without releasing too much just because of that storm. We also focus a lot on planning, and in particular, helping water resource managers be able to identify seasonal trends earlier and more confidently. So one traditional way to do this is to look at things like snowpack. HydroForecast can bring in current conditions on the ground in a basin, measuring both snow water equivalent and snow cover from a couple different data sources. And then it can also look forward and say, okay, for this reservoir in California, for instance, obviously there have been some big storms recently. We predict that over the next 30 days, flows are going to be higher than normal and keep increasing. And you can see again here, this fully probabilistic look out multiple months into the future, as well as this dotted line at the bottom, which shows the historical average. So giving guidance not just on what's expected to happen, but also how that compares to some of the benchmarks like historical averages. That data can also be grouped up in ways to look at monthly total volume, or looking at how that overall rate compares to what you've seen before. So there are different ways to sort of slice and dice the data or see further into it. And you can easily look at different forecasts from various periods. Another case where the specific actual flow predictions are useful for our operators are in looking at construction and dam maintenance. So when you're putting people or equipment either into the water or near the water, understanding how that might look compared to historical averages and what's coming in the future can be really valuable. So this, for instance, is looking at last fall at a place with pretty low flows. You can see everything is below 50 cubic feet per second. You can see starting at the beginning of the month, HydroForecast is predicting that the flows would be below average and pretty low. So that might be a good time to do some maintenance without risking anything operationally. Once that project goes on, HydroForecast can also help understand how things might change going forward and see if there are any potential risks to either the project schedule or, more importantly, personnel or equipment. So looking at the same period, you can see starting around September 17th, HydroForecast predicts a rise of a potential event that, by quantifying it and seeing how large it could potentially get, a water resource manager can understand what that risk looks like to their operations and be able to decide if they actually need to change the project schedule or change where people or equipment are ahead of time. Beyond sort of what we've focused on so far, so a lot of those technical questions of actually quantifying potential water flows and understanding what they'll look like going forward, we know that a lot of our users really care a lot about being able to communicate with other folks within their departments, with leadership or water commissioners, and with folks in their basin about what's happening. This means that if they're making decisions, they're asking someone else to make decisions, being able to give the most complete and illustrative picture of what's happening as possible can be really helpful. So in addition to actually plotting and providing this data, we focused a lot on both creating charts and plots that really show what's happening. So it's easy to see here that HydroForecast predicted this additional pulse of water, but also make that data easy to share, whether that's pulling it into a spreadsheet or looking at the table, or just taking this direct image and making it easy so that you could put it into an email or some way to share with other folks who need to be making decisions. Got two more examples, and then I'll pause so we can talk through any questions that have come up. So again, we've talked so far about actually, predicting flows, but we know that beyond that, there are a lot of ways in which the upcoming weather really is going to affect your operations. So if you think about a water resource manager, for instance, that has significant agriculture within their basin, One of the biggest drivers of demand for them is going to be if the farmers are getting natural precipitation over the coming days and what those temperatures will look like. And so as part of the process of building HydroForecast, one thing we had to do was actually just go sort of wrangle all of that data and be able to make it easily accessible. And so we pass that on to our users. So you can, for instance, set up additional weather forecast points throughout your basin that are not just where you're actually getting flow forecasts. And then we'll pass along the forecast that we're getting from a bunch of the different sources that HydroForecast is using. So you can see sort of this acronym soup here. Each of these lines is just a different forecast. This top one is the European Center's forecasts. And then these are 3 different NOAA forecasts that each provide predictions around precipitation and temperature. And so by looking through these, you can see both, okay, at this point of interest, what is the expected precipitation and temperature supposed to look like? But also, where is there disagreement about it? Where might my users not be sure if they're going to get a storm or not get a storm? And by doing so, you can better predict your demand and then also help manage your supply more effectively. The last thing that I'm going to focus on is adapting to climate change. So understanding not just what is the weather bringing over the coming days, but how is my basin likely to change over the coming decades? And that can be both total quantity of water over the course of the year, whether it's getting wetter or drier, but also timing and understanding how that's going to affect your reservoir operations. So this plot, for instance, shows a basin that each of these different box and whisker plots is a different emission scenario. And so you can imagine that the high emission scenario often creates the most change from current. And you can see here that in a high emission scenario, this reservoir is likely to get significantly more water during the late winter and early spring period. So January, February, and March. And so having this sort of information can be really helpful for water resource managers to understand, okay, if we get this additional, significant amount of water early in the year, how would we need to change our reservoir operations? Would we need different storage? And as we look at different capital investment decisions, being able to understand both this range of scenarios, but also for a specific operator, where they might be vulnerable, where there might be limits to their current operating regimes that would be tested by different inflow scenarios, can be a really useful way to begin thinking about ways to make adjustments. So for folks who are interested in learning more, understanding what it would look like to go from, understanding what HydroForecast is to having it live within your basin, we can do that process typically within under 90 days. And it's really just a matter of us understanding where you'd like forecasts, what those forecasts look like, and then taking any historic data that you have and using that to fine-tune HydroForecast's performance for your basins, conducting an evaluation, and then going live. So it's a pretty simple process. It's certainly not the historic, setting up a new process model and calibrating it that some folks might be used to. So with that, I really appreciate everyone's time so far, and I'm happy to answer any questions that you have. So if you have a question, feel free to drop it in the Q&A and we can answer it. Great. Yeah, it looks like a first question is around so the long-term scenarios. So what does this data come from? So what we've done here is we've brought in downscaled global climate models of future temperature and precipitation. And then we run those through HydroForecast to produce different inflow scenarios. And so if you think about sort of your traditional hydrologic model, you have a couple different sources of uncertainty. One is the uncertainty of the weather. Did you get the precipitation right? Did you get the temperature right? And then the other main source is the actual uncertainty in the model. And so what we know is that HydroForecast is really excellent at being able to translate things like precipitation and temperature into stream flow outputs. And so if you're working with sort of the best in class option there, then when you look really far into the future where, yeah, candidly, we don't know what those conditions will look like, being able to take sort of the best available data there and put it through a model like HydroForecast lets you see with sort of as well as we are able to at this point, what flows would look like. And in particular, it gives you a really accurate sense of what would flows look like under these specific conditions. So that if you're an expert in your basin and you can say, okay, we think that these precipitation or temperature variables seem very unlikely, we can then work with you to stretch out sort of how do you remove some of those unlikely data sets to run something that would be more representative for you and that would give a really strong representation of what flows would look like under those scenarios. Great. Any other questions? Sure. So we've got a question about plugging HydroForecast into other systems and sort of what HydroForecast looks like in comparison or alongside other forecasting services. I pulled, let's go back to it. Yeah, so this example shows both HydroForecast prediction as well as the river forecast predictions. So I would say our goal is really to provide additional high quality data alongside other really good data sources. Forecasting and prediction is such a challenging world that we don't ever want to say, just turn to HydroForecast, don't look elsewhere. We think that, having an ensemble of a variety of really high quality data is most useful for folks. And so in some instances, we're able to pull in other models like the River Forecast Center or share comparisons like the long-term average. And we always do that just so that hopefully we can create a one-stop shop where all of our users are able to come together and see the same sources of data and then be able to get that data into their systems really quickly and easily. So I've shown you some screenshots from our dashboard. We also have a system, an API that allows us to plug HydroForecast directly into other data sources that you might already be using. So I'm a big fan of our dashboard. I've shown our dashboard a lot today. We have some users who honestly look at our dashboard infrequently and just get the HydroForecast data piped directly into their systems via our API. So depending on what your system is, we really have a variety of different options that could work for you. Perfect. Well, I think that's all the questions that we've got so far. I'm happy to stay on for the last few minutes if anyone else has anything. If you have any questions or want to reach out about anything, please don't hesitate to contact us. You can either go to our website and there's a contact box there, or feel free to drop me an individual note at daniel@upstream.tech. Thanks, everyone. Have a nice day.